Greetings, ladies and gentlemen. My name is Rayyan Trinyan, and today I'm going to illustrate my work. My project is about Arabic Sign Language Alphabets Translator. So I'm going to start off with the motivation, and then I'm going to illustrate my methodology. I'm going to show you the results in a demonstration, and then perhaps some, what could be the future work in a conclusion. So, we have in the Arab region about 700,000 people with deaf people, I guess, and to understand them, there are not so many people who can really understand sign language. And a solution to that is to really use an application that really translates signs into text or speech. Based on what I've seen, mainly there are two ways: image-based recognition, and there is sensor-based recognition. Most people worked on sensor-based recognition, but it's not really that convenient. On the other hand, we have image-based, which is, I guess, under research. So there are two methods mainly: gloves with visuals, in which you basically wear a glove with red color or whatever color, and it would be easy to segment your hand movements. And on the other hand, you have bare hands, which is kind of difficult. And so I chose bare hand. And let's see. So typically, what you do is that you acquire your data, and then you do some feature extraction, machine learning, and then you test it on real time. And so the data set that I'm using is actually provided by Prince Mohammed University. It's about 50,000 images, 64 by 64 grayscale images. Covers 30 standard Arabic signs alphabets. So the alphabets, in addition with L, La, and these things. And it's performed by 40 volunteers. Now, what I did is just a simple model, 2 convolutional layers with batch normalization. And the performance is quite good. And so when I saw that, I said, oh, I cracked it. But in reality, it didn't. It didn't work in real time. And the cause is that mainly the images were provided in grayscale, so segmentation was quite difficult to do, really. I thought about it, and I tried to really to get it to work. And so what I did is that I tried to imitate the dataset conditions. But the problem, there are a variety of conditions in the dataset. So for example, one of the approaches that I did is that basically you can record a specific background, and then you can move your hand, and then you can do background subtraction and then thresholding. But that didn't work because of shadow and the variety of conditions that would be really difficult to accommodate for. And so on this approach, on that dataset, this particular dataset, it didn't really work out well with all the techniques that I used. And so I decided to create my own dataset. And so I created about 1,400 images for each class, for each alphabet. And I tried to just capture the edges of the hand. So during the capturing, I do the processing at the same time. So here is the result. I actually used the same model, and it works pretty well, I guess. But let's see what happens in real time. So here is a demo, I guess. Yeah. So this is, and it works well. But notice now, it says Ra and then Wow. And because the Ra and Wow are quite similar, so it's quite difficult to really distinguish between them. But for the most part, it works really well with most alphabets. Okay, some future work it could be to create words and sentences from the different alphabets, and because sign language is actually for each country it's different. So I'm trying to really allow the user to have, to specify his country and then the different words that they actually use. And then we have, word and sentence translation, and hand tracking is actually important because it's not really convenient to use a region of interest during detection. It's not really that convenient. So in conclusion, the performance is not that bad, but it could be improved as anything else. And certainly hand tracking is on the radar.